and sharing the screen. And here we are. And before we start, I would go through steps that are classical steps for exploratory factor analysis. So, first of all, in this step we have performed previously, it is quite good to correlate my variables. You can use correlation table, but maybe better output in JASP is heat map, and you can recognize the patterns. Then the next step, which is not described here, but also quite good, is to use KMO and Bartlett test to discover whether variables are related enough. And then we would perform so-called the first solution. We would so-called extract factors, and we would decide about the number of factors. And then we would try to interpret results, and if these results, and usually these results from the first solution are not the best one for interpretation, we would decide about next step, which is called rotation. We would discuss rotation later, so we would postpone this discussion. So here I would like only to say also some general theoretical information about how exploratory factor analysis is computed. It means about extraction techniques. There are many options. If we go to JASP, if I skip into JASP, you can find these extraction techniques here in estimation method. And if you open this dialog, you can see quite a long list and different packages, of course, offer different list of these estimation techniques. I would like to say that the most common technique in statistics for the estimation of parameters is so-called maximum likelihood. The principle is that I'm able to use equation for so-called likelihood function of my data, and I'm trying to find estimates for which this likelihood function is at its maximum. So that's why it is called maximum likelihood. Unfortunately, mostly for data that are available for factor analysis, maximum likelihood is not the best option, as this maximum likelihood expects that my variables, it means manifest variables, are all scales or cardinal, and ideally that all these variables are normally distributed. And if I go back into real life examples, this is quite exception that my data would be cardinal and would be following normal distribution. That's why maximum likelihood is not usually performed in exploratory factor analysis. So that's the first discussion. You can also find basic information here on the slide number 14. The second option, and sometimes it is inside the dialog for factor analysis, sometimes it is different dialog, is the logic of so-called principal components. So in JASP, it is special technique, so it means there was a special part of the menu devoted to this technique. In SPSS, for example, you can find it inside the dialog for factor analysis. And logic of this so-called principal component is that you take the first factor that would be the best one according to explained variance. So the first factor is the strongest factor according to explained variance from original variables. The second factor would be the second best according to the criteria of explained variance, etc., etc. And you are taking individual factors to explain the most of the variance. Let's go back into the logic of factor analysis. The main goal is to describe relationships between variables. That's why we correlate it as the first step of variables. So here we have the correlations. But the main logic of principal components is not designed on correlations, but on common variance. So that's why this is called principal components. as the main goal is to explain variance, information inside variables, not relationships. That's why usually in discussion about vector analysis, there is recommended to use, instead of principal components, alternative, which is called principal axis, which is a similar technique to principal components only in the context of exploratory factor analysis. You can find these options, of course, here. So if I open estimation method, we have discussed maximum likelihood, and you can see here principal axis factoring. So if you like to apply principal components inside factor analysis in JASP, you would be performing principal axis factoring. There are also versions of estimation techniques for factor analysis that are close to regression. This is ordinary least squares, weighted least squares, and generalized least squares. So it means it is based on the estimation of difference between real correlations and correlations estimated by my model, not weighted or weighted somehow by weighting or generalized least square approach. And then there are also special approaches such as minimum chi-square, minimum rank, and minimum residual that are quite special, so we won't cover these. I would propose for our task here to apply principal axis factoring, which is maybe the best for classical sociological data. So we would apply this estimation technique. So let's go back. We can skip the difference between PC and TFA, and we can start with basic results for a case. So basic results for the first solution would be especially that I would like to know what is the relationship between individual factors and individual variables. So it means these lambdas, these factor weights are important for me. And then I would maybe like some other outputs. So I would go down. Here it is. And I can read results. So we can skip the first two outputs as we have covered KMO and Bartlett's test, and we can go down to the next outputs. You can see that by default, JASP prepared for us two factors. We will discuss about rules that can be applied for decision about number of factors, but now let's take it as it is. So we have two factors. And you can see here the values of factor weights, here 0.445, 0.741, etc., etc. And you can see also here quite a lot of blank places. The reason behind these black spaces is that here in output options in JASP, there is default that these lambdas, these factor weights below 0.4 are not presented. So I would move down, or you can click here and change the number here in this dialog. And JASP will automatically recompute for us results. So now let's check it. And let's see results here. So currently we have here these factor weights. Once again, these are technically correlation coefficients between factors. So it means columns here and individual variables. So if I go to the picture, so these are these factor weights. So these measurements of strength of relationship between factor and individual observed variable. And as far as you can see, there are quite big values for the first 5 items. So once again, it is once again discovery that maybe first 5 items have something together. There are also quite big values for the 6th, 7th, maybe 9th item as well. And also the 10th item is quite closely related to factor 1, at least more than to factor 2. This is quite common pattern for the first solution in factor analysis. So if you are performing factor analysis and if you are using principal axis or principal component analysis as the special technique, usually the first factor is very, very strong one. and explains nearly everything. And for the rest, there are only some small information added to previous factors. So for example, here H47H is quite closely related to factor 2, and this is the only item that seems to be strange outside from the 11 items that are covered in my first solution. And here we have also the table, sorry for that. So once again, the last output, which is trying to say what is proportion of explained variance by the first dimension and by the second dimension. So we can see that first dimension is a very, very strong one. Nearly 1/4 of variance of original 11 variables is described by the first dimension, first factor. The second one is very, very weak in comparison with the first one. Only approximately 6% are covered here. So in total, we are approximately slightly below 30%. So that's also the sign that the first factor is very, very strong one. It is taking nearly all items together, and it is not differentiating between items. But as far as we know, we expect that these first 5 items are maybe left-right scale, and the rest is maybe something else, maybe only 2 or 3 items here are something else, and the rest is some, let's call it rubbish or random noise. So I would like maybe, and we would perform such procedure in a few minutes, to somehow change this first solution, and we would be performing something that's called rotation of factors. But before we start to rotate, we would briefly discuss about the rules for setting of number of factors. So we would also ask for plots and 2 plots that can be quite useful for us that are offered in JASP are Scree Plot and so-called path diagram. So I would ask for these plots. So if you go down and on the right-hand side, here we have path diagram and Scree Plot. And if we wait for a minute, JASP will prepare for us pictures that can help us to interpret results, and that can help us also to decide how many factors we should select for my data. So I would go down, and here we would see in a few seconds pictures, and before JASP will compute results, I would go into my presentation, and I will give you some theoretical insight into this topic. So first of all, how we can decide about number of factors. So there are many, many rules. Most of them are quite not useful. Some of these are slightly useful, I would say, and there is no one general rule that can be applied in all cases. But the simplest rule says that I would like to have at least some level of explained variance. There are different rules in the literature, but I wouldn't propose to follow this criteria, as at least different estimation techniques are explaining different level of explained variance, and that's why this rule couldn't be general. Very well-known rule, and usually this is default in statistical packages, is so-called Kaiser's eigenvalue greater than 1 rule. In JASP, we need to slightly change this rule into the rule which would be called as rule for eigenvalue above 1. So here we have these pictures, and let's go to this picture for this Scree plot, and let's explain how this rule value greater than 1 in JASP settings, currently greater than 0 in factor analysis, works. So here the solid line is explaining my data, and it is explaining something what is called eigenvalues. So these are some values that are assigned to individual dimensions. So it means first dimension, second one, up to 11th dimension here. And these values follow the logic that they are decreasing from the biggest value to the highest value. Technically, they mean the explained variance by individual dimensions, which is also decreasing. And if I take Kaiser's rule here at the value of 0, so I would take here the line, and maybe that I would take technically here approximately 4 or 5 dimensions. I can check it in JASP. So if I open dialog and I would ask for eigenvalues above 0, JASP will recompute my result, will also change this picture. Only I need to wait, and I would get the picture which would be close to previous one, so I can use the picture from my presentation, and I would take the line at the level of 1 for principal components or 0 for exploratory factor analysis in JASP. So JASP is recomputing. In my case, maybe that you have achieved your results, and JASP will take the line here and would take a different number of dimensions. I guess that 5 dimensions would be the correct, as 1, 2, 3, 4, 5 values of this solid line is above 0. So we can check it. Yeah, here we have 5 factors, and here we have also 5 factors in factor loading stable. So that's quite well known Kaiser's rule, and this rule is quite backed in that sense that usually offer more factors than there are necessary. So that's Kaiser's rule. So I would change it once again to the previous settings to parallel analysis. I will describe this analysis in a few minutes. And the next rule, and we can go once again to presentation to this example chart. And this rule, which is called Kettle's Scree Plot, says, okay, let's take this picture of this solid line of real eigenvalues for my data and try to find where this pattern going down is changing its shape. So let's try to find, statisticians usually call it elbow. So here's the elbow, and recommendation from Kettles was, okay, take 1 less factor than there is here in the elbow point. So for example, in this case, take only 1 factor. If I go back to my picture, so I guess it is computed. Okay, here it is. So here maybe this is first elbow, or maybe second one. So maybe 1 or 2 factors is recommendation from this Kettle's recommendation. And the last one recommendation, which is maybe the best one according to data simulations, is so-called parallel analysis, which was invented by Horn. The logic of this parallel analysis is following. You take your real data eigenvalues, this solid line, and then you simulate data that are not related at all randomly, and you prepare this simulation by this second line here. And if you take the intersection of these 2 lines, so the number of factors is above this intersection. So here it says there should be 1 factor only. Unfortunately, the implementation in JASP has some minor problems, according to my opinion, as, for example, you can see here that 1, 2, 3, 4 maybe factors should be taken as the intersection of these 2 lines is here. But according to my knowledge from other statistical packages, this picture should be slightly different, and JASP correctly decided to take only 2 factors. So please don't believe to this picture currently. At least in exploratory factor analysis in JASP, there is some small mistakes for this simulated curve. So once again, take these results. So it means take this recommendation that 2 factors are recommended according to parallel analysis. So here is parallel analysis, eigenvalues, so it means Kaiser's rule, and here we can decide according to my decision manually how many factors we would take. So currently we would perform parallel analysis and 2 factors are prepared for us. And once again, this is one of the best recommendations. Okay, so that's parallel analysis. And still we have the problem that if we try to interpret my factors, we can see that there is one strong factor and the second one is quite weak one, including only one item. So that's the problem, and we would like to change the situation. So it means to divide these items maybe more symmetrically into these two factors. If we are performing two factors, and once again, we decided to choose two factors according to Horn's parallel analysis. And if I would like to change it, I need to prepare so-called rotation. So once again, if I'm going back to my steps, we have covered correlations, extraction, decision about number of factors. Slightly, we have covered also interpretation step, and currently we will be discussing about rotation. First one, discussion should be performed that rotations could be so-called orthogonal or oblique. What does it mean technically? So if I go back to this path diagram, so it means to the picture of my current solution, you can see that here we have the first factor, the second factor called principal factors. And there is nearly a wide arrow for these two components saying there is maybe no relationship for these dimensions. You can see also that these green lines means positive relationship. These slightly red lines means negative relationship. And if the line is thick, so it means it is big relationship. If it is thin, it means it is very weak relationship. So this picture is quite nice description of this table with vector loadings. So currently I can see here that the first dimension is mostly created by first 5 items, and there is no easy description for the second dimension at all. And I would like to change it by rotation. And first of all, I would rotate, and I would expect that these two dimensions are not related at all. So I expect no relationship at all. So it means very, very weak value or no value at all here. So I would take this orthogonal rotation. And there are a lot of options usually. In JASP, you can find 1, 2, 3, 4, 5, 6 options. But most common rotation, as it gives usually the best result, it means the biggest or the smallest loadings is Varimax rotation, once again invented by Kaiser. We have discussed this guy related to eigenvalues rule over 1. So I would perform Varimax orthogonal rotation, and JASP should recompute my result, also my pictures. So I would change it. And maybe that the first and the second factor will be slightly different, and maybe that the interpretation would be easier. Once again, the reason why we are performing rotation is usually I would like to interpret more easy my results. So if the interpretation of my original first solution is enough, easy enough, so there is no space for rotation. So here it is, and I can see that this picture is slightly different. I will maybe use this option for slight change of my table. So I will use value around 0.3 for blank spaces here in this table. So just will make blank spaces for values below 0.3. And we can currently read this solution, rotated solution, which is expecting that dimensions factors are not related at all. And maybe this solution will be much better. So here we have also picture. So maybe we can start with the picture, and then we would see also the table of factor loading. So currently I can see that first component is closely related to first 5 items. So once again, if I read these items out, I can recognize that it seems that this is left-right scale. I can read out also the rest of items, and we can try to imagine what could be behind these 6 items. So young people do not accept traditional values today. The best punishment for some crimes is the death penalty. The schools should teach the children to accept authority. It is necessary to always respect the law, even if some single act is wrong. Censorship of the movies and magazines is necessary for the keeping of moral standards. And the last one item is people who contravene the law should be strictly penalized. Before we start to interpret our results, I would like once again to ask you if you can see some hidden dimension, something what is common for these 6 items. If you can help me, it would be nice.
Conservative thinking and liberal thinking.
Conservative and liberal thinking, okay, that's one option. I guess that political scientists would offer slightly different wording only. They would call it as authoritarian versus libertarian approach, but this is nearly the same. So it means people who agree are conservative, or authoritarian, in another word, and people who disagree are liberal or sometimes libertarian. So this is only European tradition and American tradition controversy. Okay, so that's my expectation, that there is maybe second dimension, which is based on these 6 items. But as we can see, these patterns in my data, I can see slightly strong relationship to A47K, H, and F. So if I'm going here, so it means young people do not accept traditional values today. That's A47F. At this A47H, this is the schools should teach children to accept authority. And the last one, A47K, people who contravene the law should be strictly penalized. So it seems that only these 3 items are somehow closely related and the rest doesn't work at all in my solution. So maybe there is a space to omit these 3 items, A47G, A47I, and A47J from my solution. So that's the first recommendation from this analysis. If you like, we can also read precise results. So here we have my table with blank spaces, and I can see nearly the same pattern. So first 5 items are quite strongly related to factor 1, left-right scale. And from the rest, so it means 6 items that originally were expected to create liberal conservative or authoritarian libertarian scale, only 3 works at least partially, and the rest, G, I, and J, doesn't work at all. So it means their factor loadings are quite low. I would like to add one more comment to this table, and there is the last column, which is always called uniqueness. What does it mean, uniqueness? If I go back to pictures from my presentation, so if I go back to pictures from the beginning, so here there were these random errors, and we discussed that these are unexplained variances. So it means something what is unexplained by factor 1, factor 2, etc. And this variance, which is unexplained for every item, is called uniqueness. So these are uniquenesses for individual items. So it means that, for example, for the first item, first 2 dimensions explains only approximately 1/4, and more than 3/4 is unexplained. For the second item, it is much better, as uniqueness is only 40%, so it means approximately 60% is explained. Opposite of uniqueness is usually called communality. So communality is explained variance, uniqueness is unexplained variance. So here, these figures are quite nice, but as you can see, for previously discussed items G, uniqueness is 0.84. So it means only 60% of variance of this item are explained by these two dimensions. The rest, 84, is unexplained. For I and J, the situation is nearly even worse, 0.9, 0.86, so only 14%, and only approximately 9% are explained. The rest is unexplained by second factor. And there can be two solutions to this result. First solution could be I would omit these items. I would propose for this task to omit these three items, as they simply do not conform to my solution in the check data. Second solution could be, and maybe it would help, to add one more factor, and maybe that these three items would create the third dimension. My proposal is not to follow this step, as it wouldn't help in this case. I know this set of statements in Czech quite well, and these three items do not work at all. So the solution would be to omit these three items. So this is discussion about uniqueness, and according to uniqueness, we can decide to omit some item from my solution. So this is next output I can get from JASP. And if I go back to previous discussion, so I think there is nothing more here, and I would make only a copy of this output, and I would only ask another question. As previously, I made orthogonal rotation, so I expected that two dimensions, so once again dimension left-right scale and dimension that can be called liberal conservative scale, that are not related at all. If you go back to this picture, there is only very, very weak relationships here expected. And now I would maybe slightly change this expectation, and I would add a rotation which would expect that these two dimensions are related. And before we start this, there is a question for you. Do you expect that these two dimensions, left and right scale and liberal conservative scales, are related in the Czech Republic closely, or only a weak relationship is expected? And what could be the relationship? Positive, negative? It means whether left-oriented people would be more conservative, more liberal. What's your expectation before we start to compute results?
I would say there is some correlation.
Okay.
Let's say that the more conservative, the more leftist, let's say, or the other way around.
In the Czech Republic, you expect this result, yeah?
Yes.
Only I would like to say that in different countries we can find different patterns, but for Czech, yes, this would be the expected pattern according to previous research. So that's why, as I expect there could be a relationship for these two dimensions, I would perform oblique rotation, as in previous case, which was orthogonal rotation. It is expected that these two dimensions are not related at all. So I will change the title for data, and I would perform oblique rotation here. So I would click here into oblique, and there are once again quite a lot of options here. I would say that here for this oblique rotations, there are quite small differences between individual cases of these rotations. What is the big difference is oblique and orthogonal, but for individual orthogonal and individual oblique, the differences are quite small one. There are many recommendations in the literature what should be performed. The classical options is called Obleman. Very common recommendation currently in the literature is to use Geoman, but we can of course use also the default, which is promax. So JASP is recomputing our result, and before we start to read results, I would go into output options and I would ask for one more output, which is called factor correlation. So it means I would get the table with the value of correlation between individual factors. So here it is, and we can go back to our results. So if I check my results, so it means these factor loadings, and compared to the previous case, they are different as different rotations, and whether I rotate orthogonally or oblique gives slightly different results. For example, here you can see that A47I is slightly increased this factor loading, so maybe for this solution it is slightly better. But doesn't matter, still we have two factors and basic interpretation is still the same. And here we have the table with factor correlations. Our expectation was that those people who are on the left would be more conservative, vice versa. And you can see that correlation coefficient computed by JASP is 0.6. So it confirms our expectation, and it says that this relationship between left-right scale and between liberal-conservative scale is quite strong one. 0.6 is quite big value. So it is presented here in this special table. We have just asked for factor correlations table. We can go also, for example, to this picture, and you can see that this strength of relationship between factors is here on the picture presented by this quite thick line between these two dimensions. So this is only graphical presentation of our result. So currently, if I would try to conclude this analysis, I would give following recommendations. Maybe we would omit at least 2 or maybe 3 items. A47J, I and J should be maybe excluded, as their uniqueness is quite big one, and also factor loadings are quite small one. So that would be first recommendation. Second recommendation would be whether to rotate or not. Definitely, we would rotate in this case, as rotation helped us a lot in the interpretation of our results. And the last one, decision between rotation, which is orthogonal, so it means expects that our dimensions are not related at all, and between oblique rotation, so it means it is expected that factors are somehow related. I would choose oblique rotation here, as it seems that these two dimensions are very, very closely related. If I would go back to orthogonal rotation, so these results were quite imprecise only by the fact that I forced the solution for factors to be unrelated at all, and it was a big mistake. So my recommendation generally for factor analysis is always try as the first one oblique rotation and check the correlation coefficient for dimensions, and if it is small one, then you can skip into orthogonal rotation. If not, please keep the solution with oblique rotation, as we have here as the last solution presented on my pictures as well as in my tables. So I would go back to my presentation, and here we have, so we have covered nearly all topics and nearly all interpretation. I would only add one more comment, and then we would switch one again into JASP, and we would perform the same analysis by principal components to see that this is very close technique. So last one step that I would like to perform in factor analysis is that I would like to go back to my data and to say, okay, if these 5 variables create one dimension, let's take these together and let's create new one variable. It means new one column called left and right. If these 6 or 4 or 3 items create something together, let's create a second dimension. It means new one variable and call it liberal conservative. We call this procedure as saving of factors, or sometimes we call this procedure as factor scores. So factor score is the value of the factor for every unit in my data set, and usually it means that your statistical package will create for you a new column with the values of these factor scores. Unfortunately, the JASP is not currently offering this option, so there is no option to save factor scores in JASP. It is a general property of JASP that the JASP is not capable to save anything from your analysis into data matrix. This is based on the logic of R, so excuse for this inconvenience. And the only option in JASP would be following. I could open this dialog for computation of new variable, and I could, for example, make a mean or sum of these first 5 items. And in the second step, I would make some summation or the average of 3, 4 items from the rest. So I would make something what is called summated rating scale. This is not precisely factor scores. This is not saving factors, but it is based on previous results of factor analysis that help us to identify dimensions. So it means to say that 5 variables here are closely related, or 3 or 4 are related here. So this is only something similar to factor scores savings. Once again, JASP is not capable of saving of factor scores. So that's the end of our presentation, and I would go once again to JASP, and I would only show you closed procedure principal components. Once again, the difference between principal components and EFA is here. So for EFA, dependents are observed variables. For PC, dependents are factors. It means hidden dimensions. So that's a basic difference between these two solutions. So I would go into factor, and I would go into principal component analysis as my step. This dialog is very, very similar to previous one, so we can go very quickly through this dialog. So I would take once again all 11 variables and move it into variable sets. Once again, you can see there are rules for decision of a number of here principal components, not factors. I can rotate, I can also cancel rotation, so I would cancel rotation for the first inside. And here in output options, I can also ask for path diagram as well as for Scree Plot. So I will ask for these 2 outputs. That's all for this first inside. If I go back to the previous outputs, so you can see that for previous outputs, hidden dimensions were called as factor 1, factor 2. Here, if we go down, it is called RC1 and RC2 as components here. And here you can see once again the picture of my data. Maybe what could be the advantage, but it is not advantage, it is only based on different style of thinking. Once again, dependent variable, observed variables versus manifest variables for PC and EFA. So what can be the advantage of this technique is that these values here, so it means these analogy to factor loadings for principal components are higher than values that are presented in exploratory factor analysis. The second, let's call it once again, advantage of principal components could be that proportion of explained variance for the same data is bigger. Previously, it was 0.30 in total for 2 dimensions. Here it is 0.4. This is also a reason why, for example, in SPSS, this principal component analysis is the full technique for estimation for the first solution in exploratory factor analysis, as it gives nice results. But once again, this is only different style of thinking of the same data. So these coefficients, in spite of the fact that they are different, they are still describing the same data. So this is only artificially exaggerated here or here in comparison with previous results. If I go to substantive discussion, so here once again, the substantive discussion is, if I open this dialog, is still the same. So I have quite strong first dimension based on 1, 2, 3, 4, 5 items from the first set. So it means once again left-right scale. And there is some sign that maybe second component will be slightly more related to some items from the rest. And once again, the solution here is not maybe the best one, as some items are closely related to the first as well as the second dimension, for example, A47F, A47H. So also maybe here rotation would be useful. And once again, as we have expectation that maybe oblique rotation would be the best one, so I would make a copy. I would change the title, oblique rotation. So here it is, and I would ask for oblique rotation solution. So I guess that JASP will once again recompute my result. And this would be maybe the best result according to principal component analysis. Once again, the logic behind the principal component analysis is slightly different. So the main goal here for principal components is to describe variance, here to describe relationships. And the logic here is that factors are dependent variables, here factors are independent variables. So for our case, it means left-right scale, Ribble conservative scale. The EFI solution is much better than PC. So that's only for you to know. And here, if I change into oblique rotation, so you can see quite nice picture for the first dimension, and also quite nice picture for the second dimension, but still two items with quite low factor loadings or component loadings here, as it is about components here, can be seen. So once again, recommendation that at least two items should be omitted. Once again, if you compare these figures with previously rotation of factor analysis, so here it is, this is factor loadings for oblique rotation. So these values for principal components seems much better. But once again, these are the same data, and this is only difference in the technique we have applied. So these figures are nearly the same picture as previous, only by different technique. But once again, I would like to say that people usually like this principal components, as these figures here in component loadings, as well as here in explained variance, are usually much better. Also, it means that these uniquenesses are lower than for the case of exploratory factor analysis. So this is only the last one comment to our description of principal component analysis and comparison of exploratory factor analysis and principal component analysis in JASP. So if I conclude our discussion, so we have discovered by our analysis that first 5 items here create one dimension that we could call left-right scale. And from the rest, there are maybe 4, maybe 3 items that create something that could be called as liberal conservative scale. At least two of these items should be excluded from my analysis. I guess it was the best punishment for some crimes, death penalty, and also it is necessary to always respect the law, even if something like this wrong. These two items were the worst one in my solution. So that's all for today's lecture about exploratory factor analysis. So I would stop sharing and recording.